How can motor circuits avoid overloads with correct fuse sizing? Imagine a motor starting up and suddenly tripping a circuit breaker. That can be frustrating, but it's often preventable with the right fuse size. When designing motor circuits, choosing the correct fuse is key to avoiding overload problems. Motors draw a lot of current when they start, called inrush current. This temporary surge can be 2 to 3 times the normal running current. Fuses need to handle this surge without blowing unnecessarily. That's why selecting the right fuse size is so important. If the fuse is too small, it will trip during startup, causing delays and downtime. If it's too large, it might not protect the motor properly during actual overloads or faults. There are 2 main types of fuses used in motor circuits. Fast-acting fuses respond immediately to overcurrent, which is good for protecting equipment but can trip during motor startup. Time delay fuses, also called dual-element fuses, can withstand brief surges, allowing the motor to start smoothly. They only trip if the overload persists beyond a certain time. The general rule for fuse sizing is to set the fuse at about 125% of the motor's full load current if the motor has a service factor of 1.15 or higher. The full load current is listed on the motor's nameplate. For example, if a motor's full load current is 25 amps, the fuse should be around 30 amps. If the calculated fuse size isn't a standard rating, choose the next lower standard size to avoid oversizing. For motors without a high service factor, the maximum fuse size is usually around 115% of the full load current. When protecting the entire branch circuit, dual-element fuses can be sized up to 175% of the full load current, mainly for short-circuit protection. Fast-acting fuses can go up to 300%, but these are mainly for short-circuit conditions, not overloads. In systems with overload relays, the fuse acts as backup protection. The relay monitors the motor's current over time and trips if it detects a sustained overload. The fuse, sized properly, will only trip during severe faults or short circuits. This coordination ensures the motor is protected without unnecessary trips during normal operation. In real-world applications, choosing a time delay fuse for motor circuits is common because it handles startup surges well. For example, if a motor has a 24.5 amp full load current, a 30 amp fuse would be suitable. It allows the motor to start without tripping but will open if a serious overload or fault occurs. Special considerations are needed for AC-style motor starters, which have lower withstand capabilities. In these cases, selecting a fuse between 125 and 150% of the full load current helps match the starter's characteristics. Remember to always use the motor's nameplate data for calculations. Proper fuse sizing and coordination with overload relays help prevent overloads, reduce nuisance trips, and keep your system running smoothly. Selecting the right fuse size is a simple but vital step in protecting your motor circuits effectively.